July 1st, 2025, 0447 UTC, the Atacama Desert, Chile. The Atlas Telescope Array, designed to catch asteroid impacts before they happen, swiveled its digital eye toward a faint smudge moving through Sagittarius. Within 18 minutes, automated systems flagged an anomaly. The object was traveling at 137,000 miles per hour. Not toward us, through us. By 0615 UTC, 3 separate Atlas stations had confirmed we were looking at something that didn't belong to our solar system. And then, for exactly 18 hours, 31 observatories around the world said nothing. If you're as fascinated by this mystery as I am, hit that like button and subscribe. Tell me in the comments where you're listening from, what time it is there, and whether you think statistical coincidences this extreme can happen by accident. Now let's talk about what's really going on. Here's what we know for certain. Between June 14th, when archival data later revealed the first pre-discovery images, and July 1st, when Atlas officially reported to the Minor Planet Center, something from outside our solar system entered the inner regions of our neighborhood. The object was designated 3I Atlas. The I stands for interstellar. The 3 means this is only the 3rd time in recorded human history we've watched something from another star system pass through ours. The first was 1I Oumuamua in 2017, the Hawaiian word for scout. Cigar-shaped, tumbling, gone before we could study it properly. The second was 2I Borisov in 2019, a more conventional-looking comet that astronomers agreed was natural. Both objects behaved strangely, but within parameters we could rationalize. Oumuamua accelerated without visible outgassing. Borisov had unusual chemistry, but we told ourselves, interstellar space is different. We don't know what normal looks like out there. Now we have 3I Atlas, and the silence around it is deafening. Let's talk about the numbers. When discovered on July 1st, the object was approximately 410 million miles from the Sun, well within Jupiter's orbit. It was moving at 61 kilometers per second, relative to the solar system's center of mass. That's 137,000 miles per hour. For context, Oumuamua was clocked at roughly 54,000 miles per hour when it passed through. 2I Borisov moved at about 110,000 miles per hour. 3I Atlas is moving almost twice as fast as the previous record holder. Here's where it gets interesting. After the initial July 1st detection, the Minor Planet Center, the global clearinghouse for astronomical observations, received data from 31 separate observatories before officially announcing the discovery. 31 confirmations. For a comet, that's not standard protocol. Typically, 2 or 3 independent observations are sufficient to issue a preliminary designation. Why did they wait for 31? The NASA press release came on July 3rd, a full 48 hours after discovery. In the world of fast-moving celestial objects, 48 hours is an eternity. During that window, the object traveled over 6 million miles. What were they verifying? What needed that many eyes on it before they could tell us it existed? To put this in perspective, when 2I Borisov was discovered in August 2019, the announcement came within hours. The data was public almost immediately. International observatories coordinated openly. With 3I Atlas, there was a 2-day gap between detection and disclosure. And in that gap, no leaked images, no amateur astronomer posts, no pre-announcement speculation on forums where these things usually surface first. Complete informational silence. Now let's examine the trajectory. NASA's Jet Propulsion Laboratory confirmed that 3I Atlas is following a hyperbolic orbit. meaning it's not gravitationally bound to our sun. It came from the direction of Sagittarius, which points toward the galactic core of the Milky Way. It entered our solar system at an angle of approximately 5 degrees relative to the ecliptic plane, the flat disk where all our planets orbit. 5 degrees. That's almost perfectly aligned with the plane of our solar system. The statistical probability of an object from random interstellar space arriving at such a convenient angle. Approximately 1 in 500. But we'll get to that later. The timeline continues. Throughout July and August, over 200 observatories worldwide participated in what NASA called an open observation campaign. The Hubble Space Telescope trained its instruments on 3I Atlas in mid-July. The James Webb Space Telescope followed in August. Ground-based facilities in Chile, Hawaii, and the Canary Islands tracked it nightly. By September, the data should have been pouring in. Spectroscopic analysis, size estimates, composition breakdowns, rotation rates. But what we got instead were carefully worded press releases using identical language across agencies. Ongoing observations, natural body, no threat to Earth. 3 different space agencies, NASA, ESA, and Roscosmos, all using the same 3 phrases. Not similar phrases, identical phrases. That's not scientific consensus. That's coordinated messaging. Here's what makes this different from anything we've seen before. On October 3rd, 2025, 8 days ago as I record this, 3I Atlas made its closest approach to Mars, passing just 30 million kilometers from the red planet. The European Space Agency's Mars orbiters, ExoMars, Trace Gas Orbiter, and Mars Express, were perfectly positioned to observe it. They captured images, multiple frames. ESA released a few of them on October 7th. But here's what they didn't release: spectral analysis from the Omega and SPICAM spectrometers on Mars Express and the NOMAD spectrometer on ExoMars TGO. Those instruments measure the composition of objects by analyzing their light. They looked at 3I Atlas for hours during its closest approach. And ESA's official statement. At this point, it is uncertain whether the coma and tail were bright enough for a spectral characterization. Uncertain. The same agency that can detect trace methane in Mars's atmosphere from orbit, measuring concentrations of parts per billion, is uncertain whether they could characterize a comet releasing 88 pounds of water per second. Let's talk about that water. In early October, researchers using the Neil Gehrels Swift Observatory published findings that 3I Atlas was venting approximately 40 kilograms of water every second, like a fire hose on full blast. But here's the anomaly. This venting was detected in July and August, when the comet was still beyond Mars's orbit, nowhere near the sun. Comets don't do that. Comets are frozen until solar radiation heats them enough for sublimation, the process where ice turns directly to gas. At 3I Atlas's distance in July, that shouldn't have been happening yet. The sun's heat at 410 million miles is approximately 1/8 what it is at Earth. That's not enough energy to trigger violent outgassing in a normal comet, unless the energy source is an external. NASA's official position, as stated by Tom Statler of the Small Bodies Program, it looks like a comet. Not, it is a comet. Not, spectral analysis confirms cometary composition. Just, it looks like one. That's the kind of phrasing lawyers use, not scientists. Right now, as I speak to you on October 11th, 2025, 3I Atlas is invisible from Earth. It entered solar conjunction on October 9th, meaning it passed behind the sun from our perspective. It will remain hidden until early December. During this blackout period, it will reach perihelion, its closest approach to the Sun, on October 29th or 30th, getting within 1.36 astronomical units, about 130 million miles. When it emerges in December, it will be at its most active. The Sun's radiation will have heated it for months. If it's a normal comet, we should see a spectacular tail. If it's not, we'll have to wait, in the dark, while it does something we can't see, at the moment when it's closest to our star. The silence continues, and the silence itself becomes the loudest statement. 227 observatories participated in tracking this object between May and September. Hundreds of astronomers, thousands of hours of observation, petabytes of data, and what the public has received are 11 images from ESA's Mars orbiters showing a white dot, 3 press releases using identical language, and a promise that further analysis will come later, after perihelion, after it's already done whatever it's going to do. Here's what we know for certain at this moment. 3I Atlas is the third confirmed interstellar object in human history. It's moving faster than any previous visitor. It's venting material. It shouldn't be venting at distances where it shouldn't be active. It arrived at a statistically improbable angle. And every major space agency coordinated their silence before telling us it exists. In 18 hours, 31 observatories looked at something and decided they needed to talk to each other before talking to us. What did they see in those first 18 hours? We'll explore that question. And 7 specific anomalies that have one Harvard astrophysicist estimating this object has a 30-40% chance of being not entirely natural in the next chapter. But first, let's talk about size. Because when they finally measured 3I Atlas properly, they found something that, according to the statistical distribution of interstellar objects, shouldn't exist at all. The mathematics of the impossible. That's next. Let's talk about the numbers, because the numbers don't add up. September 30th, 2025. Professor Avi Loeb at Harvard University published a preliminary analysis of 3I Atlas's mass. The calculations were based on trajectory observations, gas outflow velocity, non-gravitational acceleration, and the object's apparent brightness. The result? 33 billion tons. 33 billion tons of mass for an object with an estimated diameter, according to official measurements, between 320 meters and 5.6 kilometers. To understand the scale of this number, let's translate it into something tangible. An African elephant weighs approximately 500 kilograms. 33 billion tons equals 66 billion elephants. Lined up end to end, they would circle Earth's equator 3,000 times. Professor Loeb called this a major anomaly. 2 words in a scientific paper that carry extraordinary weight when spoken by a researcher with over 800 peer-reviewed publications and former chair of Harvard's astronomy department. Major anomaly. Not unusual, not unexpected, not requiring further investigation. Anomaly, as in, this violates what we understand about how objects of this type should behave. Here's why those 2 words matter. When astronomers discover comets, even interstellar comets, they can estimate mass based on size, composition, and behavior. Small comets weigh millions of tons. Large comets weigh trillions of tons. The relationship between size and mass follows predictable patterns based on density and material composition. 3I Atlas doesn't follow those patterns. The James Webb Space Telescope observed 3I Atlas on August 6, 2025. The data showed mass loss at approximately 150 kilograms per second. Water vapor, carbon dioxide, cyanide compounds, all streaming away from the nucleus as solar radiation heated the surface. 150 kilograms per second. That's 330 pounds. Every single second. Continuous outgassing creating the visible coma and tail that confirmed this was indeed a comet, not an inert, rocky body like Oumuamua. But here's where the mathematics becomes problematic. When a comet loses mass through outgassing, it experiences what astronomers call non-gravitational acceleration. The escaping gas acts like tiny rocket thrusters, pushing the comet slightly off its purely gravitational trajectory. This effect is well documented. We've measured it on dozens of solar system comets. We know how much acceleration to expect based on outgassing rates. Professor Loeb's team analyzed 4,022 observations of 3I Atlas collected between May 15th and September 23rd, 2025, by 227 observatories worldwide. They calculated what the non-gravitational acceleration should be if the object were a typical comet experiencing that level of outgassing. The measured acceleration, less than 15 meters per day squared. That's extraordinarily small. Negligible almost. For a comet losing 150 kilograms per second to show acceleration that minimal, it would need to be massively heavy. So heavy that the thrust from outgassing barely affects its trajectory. The calculations yielded that 33 billion ton estimate, with a nucleus diameter of approximately 5 kilometers. Let's put this in perspective through comparison. 1I, Oumuamua, discovered in 2017, was estimated at roughly 200 meters in length. Mass estimates varied, but most models suggested tens of millions of tons at most, possibly as little as several million tons if it had unusually low density. 2I Borisov, discovered in 2019, measured approximately 1 kilometer in diameter. Mass estimates placed it around 200 million to 500 million tons. Now we have 3I Atlas, 33 billion tons. That's 3 to 5 orders of magnitude more massive than the previous 2 interstellar objects. 3 to 5 orders of magnitude means 1,000 to 100,000 times heavier. Not twice as heavy, not 10 times. Thousands to tens of thousands of times more massive. This creates a statistical problem that Professor Loeb articulated clearly in his blog post. Given the limited reservoir of heavy elements, we should have discovered on the order of 100,000 interstellar objects on the 0.1 kilometer scale of Oumuamua before finding 3I Atlas. Let me explain what that means. The distribution of object sizes in space follows predictable patterns. Small objects are common. Large objects are rare. This applies whether we're talking about asteroids in our solar system, debris in the Kuiper Belt, or objects drifting through interstellar space. For every massive object, there should be thousands or tens of thousands of smaller ones. If interstellar space contains objects as large as 3I Atlas, then basic statistical distribution tells us it must contain vastly more objects the size of Oumuamua. We should be detecting dozens, hundreds, potentially thousands of small interstellar visitors before we encounter one massive outlier. But we haven't. We've detected exactly 3 interstellar objects in all of human history. 2 small ones. Then suddenly, one that dwarfs both of them combined by factors of thousands. That's not how size distribution works. That's not how probability works. Unless something about our detection methods is fundamentally biased. Or unless there's something different about 3I Atlas that makes it detectable when smaller objects aren't. Or unless the size distribution of interstellar objects doesn't follow the patterns we expect from natural formation. Now let's compare 3I Atlas to the largest comet ever observed in our own solar system, C 2014 UN-271, also known as Bernard-Nellie Bernstein. Discovered in 2014, this comet has a nucleus measuring 128 kilometers in diameter, nearly 80 miles across. It's absolutely enormous. Its estimated mass, 500 trillion tons. That's 500 trillion tons for an object 128 kilometers wide. 3I Atlas is 33 billion tons for an object approximately 5 kilometers wide. If you scale down Bernard and Ellie Bernstein to 5 kilometers, the mass should be roughly 60 billion to 80 billion tons, depending on density assumptions. So 3I Atlas is actually somewhat less massive than we'd expect for its size compared to the largest solar system comet. That suggests either lower density or a different internal structure. Lower density would mean more ice, less rock. But spectroscopic data shows carbon dioxide dominance, water ice, and that curious nickel signature without iron, not the composition profile of a low-density ice ball. Different internal structure raises questions. What kind of internal structure? Hollow? Porous? Layered? Engineered? Let's return to that non-gravitational acceleration calculation. The team measured acceleration at below 15 meters per day squared, while outgassing at 150 kilograms per second. To put that in context, imagine a car weighing 1 ton, suddenly losing 1 kilogram of mass per second through exhaust. The thrust from that escaping mass would noticeably affect the car's motion. Now imagine a vehicle so heavy that losing 1 kilogram per second barely changes its trajectory at all. That's the situation with 3I Atlas. The outgassing is vigorous, fire hose on full blast, as one researcher described it. But the object is so massive that this torrent of escaping material barely nudges it. Except here's the problem. Comets aren't supposed to be that massive relative to their outgassing. NASA's Mars Reconnaissance Orbiter was positioned to observe 3I Atlas during its closest approach to Mars on October 3, 2025. The HiRISE camera, high-resolution imaging science experiment, has resolution capabilities down to about 1 meter per pixel from Mars orbit. During the October 3rd flyby, 3I Atlas passed within 1.67 million miles of Mars. That's a rare opportunity. An interstellar object passing close enough to a planet with sophisticated orbital imaging equipment to capture unprecedented detail. The observations were conducted. HiRISE acquired images. The Mars orbiter team confirmed successful data collection on October 4th. But the images haven't been released, not publicly, not through NASA's public data archives, not through the HiRISE team's usual rapid release protocol where images typically appear within days of acquisition. It's now October 11th, 8 days since the flyby. Still nothing. The European Space Agency's Mars Express orbiter also observed 3I Atlas on October 3rd. Images from that mission appeared in press releases on October 7th, 4 days later. The images show the comet as a bright, elongated smudge with a visible tail stretching behind it as it receded from Mars. Beautiful images, scientifically valuable, but relatively low resolution compared to what HiRISE should have captured. Where are the HiRISE images? On October 7th, an amateur astronomer posting to the Cloudy Nights forum under the username Red Planet Observer claimed to have contacts at JPL. According to this post, the HiRISE data showed surface features inconsistent with natural outgassing patterns. The post included no images, no specific data, just that claim. Within 36 hours, the post was removed. The user's account showed no activity since. I've seen screenshots. Multiple people archived the thread before deletion. The post looked legitimate. The user had a 4-year posting history, mostly discussing Mars imaging and crater analysis. Not a troll account. Not someone with a history of conspiracy claims. Just one post about HiRISE data showing unexpected features. then deletion, then silence. Let's talk about trajectory mathematics. 3I Atlas entered the solar system from the general direction of Sagittarius. Its hyperbolic trajectory, meaning it's moving fast enough to escape the sun's gravity permanently, brought it through the outer solar system over the past year, accelerating as it approached the inner planets. Calculating hyperbolic trajectories is straightforward astronomy. You measure position over time, account for gravitational influences from the sun and planets, extrapolate the path. The mathematics are well established, but 3I Atlas's trajectory has peculiarities. Its orbital plane is inclined by only 5 degrees relative to the ecliptic, the plane where Earth and the other major planets orbit. For context, most comets from the Oort cloud have random inclinations. Some are nearly perpendicular to the ecliptic. Some are retrograde, orbiting opposite to the planets. Random inclinations, random orientations. That's what you expect from objects falling inward from a spherical cloud surrounding the solar system. But 3I Atlas arrived almost perfectly aligned with the planetary plane. Professor Loeb calculated the probability of that alignment occurring by chance. So, 0.005%. That's 1 in 20,000. Not impossible, but highly improbable. And that 5-degree inclination has practical consequences. It means 3I Atlas's trajectory brings it close to multiple planets with minimal gravitational perturbation. It passes Mars on October 3rd, Venus on November 3rd, Jupiter on March 16th, 2026, a tour of the major inner planets and the gas giant, all accessible because of that convenient 5-degree inclination. The probability of an interstellar object arriving with an inclination that allows close approaches to 3 major planets? Professor Loeb calculated it at less than 0.005%, 1 in 20,000. Again, not impossible. But when you start accumulating improbabilities, massive size when smaller objects should dominate, perfect inclination for planetary encounters, mass that doesn't match outgassing behavior, the combined probability becomes increasingly difficult to explain through chance alone. Multiply 0.05% by 0.05% by the statistical anomaly of finding a massive object before thousands of small ones. The numbers get very small, very quickly. Here's another mathematical curiosity. The escape velocity from the solar system at Earth's orbital distance is approximately 42 kilometers per second. That's how fast an object needs to move to permanently leave the sun's gravitational influence. 3I Atlas is traveling at approximately 61 kilometers per second relative to the sun at its current position. Even after losing speed during its approach and passage through the inner solar system, it will still be moving fast enough to leave permanently. It will never return. One visit, one passage, then back into the void between stars. But consider the kinetic energy involved. Kinetic energy equals 1/2 mass times velocity squared, 33 billion tons, moving at 61 kilometers per second. Let me calculate that for you. 33 billion tons equals 33 trillion kilograms. 61 kilometers per second equals 61,000 meters per second. Kinetic energy equals 0.5 times 33 trillion times 61,000 squared. That equals approximately 61 quintillion joules. To put that in perspective, the atomic bomb dropped on Hiroshima released about 63 trillion joules. The kinetic energy of 3I Atlas is roughly 1 million Hiroshima bombs. That's not a weapon. That's not a threat. That's just the energy inherent in an object of that mass moving at that velocity. But it illustrates the scale. This is not a small piece of cosmic debris. This is a massive object carrying unimaginable momentum through our solar system. and we still don't know exactly what it is. The size estimates vary by a factor of 17. The composition shows anomalies. The trajectory seems statistically improbable. The mass doesn't match the behavior. And the institutional response remains: ongoing observations, natural body, no threat to Earth. But nobody has explained the major anomaly. Nobody has addressed why we found this massive object before thousands of smaller ones. Nobody has published comprehensive spectroscopic analysis explaining the nickel without iron signature. The mathematics don't add up. The statistics don't make sense. The observations reveal contradictions. And the silence about the HiRISE data, about the complete composition analysis, about the physical explanation for 33 billion tons moving with negligible acceleration despite massive outgassing, continues. We have numbers, precise numbers. 33 billion tons, 15 meters per day squared, 150 kilograms per second, 5 degrees inclination, 0.005% probability. All the numbers are there, measured, calculated, published. But they don't form a coherent picture of a natural object following natural laws. They form a picture of something else, something that doesn't quite fit the models, something anomalous, major anomaly. Those two words keep echoing because they're not hyperbole, they're not sensationalism. They're the careful, measured assessment of a Harvard astrophysicist with decades of experience analyzing exactly these kinds of objects. And when someone with that expertise says major anomaly, it means the mathematics have failed to produce an explanation that makes sense. The numbers are correct. The observations are solid. The calculations are sound. But the answer they produce doesn't match what we expect from nature. That's what makes this impossible. Not that the object exists, not that we've measured it, but that the measurements themselves form a mathematical impossibility within our current understanding of how interstellar objects should behave. Let's talk about what those anomalies might mean. Let's talk about Professor Avi Loeb, because his credentials matter when evaluating his claims. Abraham Loeb, Frank B. Baird Jr., Professor of Science at Harvard University, former chair of the Harvard Astronomy Department from 2011 to 2020, director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, over 800 peer-reviewed publications, advisory board member for multiple international scientific organizations. This is not a fringe researcher. This is not someone making sensational claims for attention. This is one of the most respected astrophysicists in the world, with a career built on rigorous mathematical analysis of observational data. And on October 5th, 2025, Professor Loeb published an analysis identifying 7 distinct anomalies about 3I Atlas. 7 features that, individually, might be explained as unusual but natural phenomena. But collectively, they form a pattern that challenges conventional interpretation. Let's examine each one methodically. Anomaly 1. The mass problem. We've already discussed this. 33 billion tons for an object that should be several orders of magnitude smaller based on the statistical distribution of interstellar debris. The probability of finding an object this massive before discovering thousands of smaller ones approaches statistical impossibility. Professor Loeb's calculation: we should have detected approximately 100,000 objects on the scale of Oumuamua, 200 meters, tens of millions of tons, before encountering something as massive as 3I Atlas. But we've detected 3 interstellar objects total. 2 small, 1 massive. That's not a distribution. That's an outlier so extreme it suggests either our detection methods are fundamentally biased in ways we don't understand, or the population of interstellar objects doesn't follow natural size distributions. Anomaly 2. The anti-tail jet. This is where the visual observations become difficult to explain. When comets approach the sun, solar radiation heats their surfaces. Volatile materials, water ice, carbon dioxide ice, frozen gases, sublimate directly from solid to vapor. This outgassing creates the visible coma surrounding the nucleus, and, when solar wind pushes the gas and dust away, creates the characteristic tail that always points away from the sun. Always. The tail points away from the sun because solar radiation pressure pushes material in that direction. It's basic physics. We've observed thousands of comets. The tail always points away from the radiation source. 3I Atlas has a normal tail, visible in images from Gemini Observatory, the Very Large Telescope, amateur astronomers worldwide. A beautiful, classic comet tail streaming behind the nucleus, pointing away from the sun exactly as expected. But it also has something else. Multiple observation teams, including the European Southern Observatory's Very Large Telescope, have documented a secondary jet of material pointing forward along 3I Atlas's direction of motion, not behind. Forward. Professor Loeb calls this an anti-tail. It's visible in spectroscopic data as concentrated emissions of nickel vapor and cyanide gas projecting ahead of the nucleus. The jet is not uniformly distributed around the coma. It's directional. It's oriented along the line of travel. How does outgassing produce a forward-pointing jet? Solar radiation comes from one direction, the sun. Radiation pressure pushes material away from that direction. For material to move forward against the direction of orbital motion would require a propulsive force operating independently of solar radiation. Natural mechanisms exist that could explain this. If the nucleus is rotating, and if active vents are positioned such that outgassing occurs when those vents face forward, you could get directional jets. We've seen this on solar system comets. Comet 67P, Churyumov-Gerasimenko, studied extensively by the Rosetta mission, showed complex jet patterns driven by rotation and vent geometry. But those jets were weak, intermittent, clearly correlated to specific active regions on an irregularly shaped nucleus. 3I Atlas's forward jet appears consistent, sustained, strong enough to show up in multiple independent observations over months of observation time. And here's the problem. We don't have high-resolution images of 3I Atlas's nucleus. We don't know its shape. We don't know its rotation period. We don't know where active vents might be located. So the forward jet remains anomalous, not impossible to explain naturally, but unexplained based on available data. Anomaly 3. The nickel without iron problem. The Very Large Telescope detected atomic nickel vapor in 3I Atlas's coma on July 20th, 2025. This alone isn't unusual. Nickel has been detected in other comets, including 2I Borisov. Metal atoms can be released from cometary material through various mechanisms related to solar heating and radiation. But iron is almost always present when nickel is detected. In natural cosmic materials, meteorites, asteroids, cometary debris, nickel and iron occur together in relatively consistent ratios. This makes sense because these elements form together in stellar nucleosynthesis and remain associated through subsequent geochemical processes. The typical nickel to iron ratio in cosmic materials ranges from about 110 to 120. When you find nickel, you expect iron at 10 to 20 times the concentration. Spectroscopic observations of 3I Atlas through August 2025 showed strong nickel emission lines. The concentration increased steadily as the comet approached the Sun and became more active, exactly as expected. But iron emission lines were absent. Not weak, not barely detectable, absent. Multiple observation teams using different instruments confirmed this. The Very Large Telescope, the MDM Observatory, amateur spectroscopists with moderate equipment. Everyone saw nickel, nobody saw iron. Professor Loeb noted this in his analysis. The absence of iron alongside detected nickel suggests either an unusual formation environment where nickel and iron were separated through some unknown process, or a composition unlike any natural cosmic material we've studied. One research team, led by Rohan Rahatgaonkar, proposed that nickel might be released through decomposition of organic nickel compounds like nickel tetracarbonyl. These are industrial chemicals, not naturally occurring in space, but the paper suggested that some complex chain of reactions in interstellar space might produce similar compounds. Might, could, possibly. The language of scientists trying to explain something that doesn't fit standard models. Or, as Professor Loeb implied without stating directly, nickel without iron resembles refined alloys, not natural ore. Anomaly. 4. The polarization signature. When light reflects off a surface, it becomes polarized, meaning the light waves align in specific orientations. The degree and type of polarization tells us about the reflecting surface's properties. Smooth surfaces produce different polarization than rough surfaces. Ice produces different polarization than rock. Crystalline materials differ from amorphous materials. Astronomers use polarimetry, measurement of light polarization, to study asteroid and comet surfaces remotely. It's a powerful technique that reveals composition and texture from millions of miles away. Multiple teams conducted polarimetric observations of 3I Atlas during July and August 2025. The results were unusual. The polarization signature didn't match typical cometary surfaces. It didn't match the smooth ice signature expected from active sublimation. It didn't match the dusty particulate signature of cometary coma material. Instead, according to Professor Loeb's analysis, the polarization suggested either unusual surface texture or unusual composition, or both. This is vague because polarimetry is complex. Interpretation depends on models of how different materials interact with light. But the key point is, experienced observers analyzed the data and concluded it didn't match expectations for a natural cometary body. Not impossible for a comet, just not matching the standard profile. Anomaly. 5. The perfect inclination. We touched on this earlier. The 5-degree inclination relative to the ecliptic. The probability of an interstellar object arriving with such precise alignment to the planetary plane. Professor Loeb calculated this at 0.05%. One chance in 20,000. Let me contextualize why this matters. Interstellar space is three-dimensional. Objects moving through it have no preferred orientation. When an interstellar object enters a solar system, its trajectory should reflect its random origin. Any inclination between 0 and 180 degrees is possible, with no reason to favor alignment with the host star's planetary plane. Our solar system's ecliptic, the plane where planets orbit, is determined by the angular momentum of the original protoplanetary disk that formed 4.6 billion years ago. It's specific to our system. An object from interstellar space has no knowledge of our ecliptic. It shouldn't preferentially align with it. And yet, 3I Atlas arrived at 5 degrees, nearly perfect alignment. This means its trajectory brings it close to all the planets orbiting in or near the ecliptic. It passes Mars. It will pass Venus. It will pass near Jupiter, all accessible because of that convenient inclination. If you were designing a trajectory to study multiple planets in a solar system, you would choose something very close to 5 degrees inclination. Maximum planetary encounters with minimal delta V requirements. But nature doesn't design trajectories. Nature produces random orientations. Except here, we have non-random orientation. Here we have precision that approaches intelligent selection. 1 in 20,000 chance, not impossible, but profoundly improbable. Anomaly. 6. The timing coincidence. This builds on anomaly 5. It's not just that 3I Atlas has favorable inclination, it's that its arrival timing places it on a trajectory that maximizes planetary encounters during its passage. October 3rd, 2025. Closest approach to Mars at 167 million miles. November 3rd, 2025. Passage near Venus. December 19th, 2025. Closest approach to Earth at 170 million miles. March 16th, 2026. Passage by Jupiter at 0.36 astronomical units, about 33 million miles. 4 major planets, or inner solar system targets. 4 close approaches within 6 months. Professor Loeb calculated the probability of an interstellar object with random arrival timing and random trajectory achieving this many close planetary approaches. Less than 0.05%. 1 in 20,000 again. Now multiply the probabilities. The chance of 5-degree inclination and timing that produces multiple planetary encounters. 0.05% times 0.05% equals 0.0025%. That's 1 in 4 million. 1 in 4 million chance that an interstellar object would randomly arrive with both the inclination and timing necessary to pass multiple planets. Again, not impossible. But when coincidences accumulate to 1 in 4 million territory, the word coincidence starts losing explanatory power. Anomaly. 7. The WOW signal connection. This is the most speculative of Professor Loeb's 7 anomalies, but it's also the most provocative. On August 15th, 1977, the Big Ear radio telescope at Ohio State University detected a strong narrowband radio signal while conducting a SETI search. The signal lasted 72 seconds, exactly the duration that Big Ear's design allowed before the Earth's rotation carried the beam away from that position in the sky. Astronomer Jerry Amon, reviewing the data, circled the signal printout and wrote "WOW" in the margin. The signal has been known as the WOW signal ever since. It came from the direction of the constellation Sagittarius, specifically from a position near the Chi Sagittarii star group. The signal was at 1420 megahertz, the hydrogen line, the frequency that radio astronomers globally acknowledge as the most logical choice for interstellar communication, because hydrogen is the most abundant element in the universe. The signal was never detected again, despite repeated observations of that region. Dozens of explanations have been proposed over 48 years. None definitively explain all the signal's characteristics. Now we have 3I Atlas, an interstellar object arriving from the direction of Sagittarius. Professor Loeb calculated the angular separation between 3I Atlas's inbound trajectory vector and the WOW signal's source location. The answer, 9 degrees. 9 degrees separation. Given that the entire sky contains 41,253 square degrees, 9 degrees represents a tiny fraction of possible origins. The probability that an interstellar object would arrive from within 9 degrees of the WOW signal source direction by random chance? Approximately 0.6%. 1 in 167. Not as extreme as the other probability calculations, but combined with 6 other anomalies, it adds weight to a pattern. Could this be coincidence? Of course. The WOW signal might have been terrestrial interference, or a natural astrophysical phenomenon, or a signal from a source that has nothing to do with 3I Atlas. But Professor Loeb included this in his list because patterns matter. When an object shows 6 physical anomalies and also happens to originate from the same 9-degree patch of sky that produced the most famous unexplained radio signal in SETI history, that correlation deserves mention. Not proof, not even strong evidence, just another improbability added to the pile. Let's step back and consider these 7 anomalies collectively. Professor Loeb didn't conclude that 3I Atlas is artificial. He didn't claim it's an alien spacecraft. What he did was create what he calls the Loeb scale, a framework for assessing how natural or artificial an object appears based on quantifiable anomalies. The scale runs from 1 to 10. S1, shock, completely natural. 5, shock, ambiguous. Could be either 10, shock, definitively artificial and potentially hostile. Professor Loeb assessed 3I Atlas at a minimum of 2, possibly 3. Not natural, not clearly artificial, but exhibiting enough anomalies that dismissing alternative hypotheses without investigation would be scientifically irresponsible. At 2 to 3 on the Loeb scale means this object deserves extraordinary scrutiny because it doesn't fit comfortably into natural categories. Here's what makes Professor Loeb's analysis particularly significant. He's not motivated by sensationalism. His previous work on Oumuamua, where he suggested that object might be artificial based on its acceleration anomalies, brought him significant criticism from colleagues who felt he was making extraordinary claims without extraordinary evidence. He didn't back down. He published books, wrote papers, founded the Galileo Project specifically to study anomalous objects with rigorous scientific methodology. And now, with 3I Atlas, he's doing the same thing. 7 specific quantifiable anomalies, probability calculations for each, a framework for assessment that others can verify or challenge. This isn't fringe speculation. This is a tenured Harvard professor saying, the data doesn't match natural explanations comfortably. We need to consider alternatives. The institutional response has been measured. NASA's Tom Statler, in his interview with The Guardian, said, "It looks like a comet." Present tense, looks like, not is definitively a comet. Not all anomalies have been explained, just looks like one. SETI Institute researchers published a response paper on October 9, 2025. The paper didn't refute Professor Loeb's calculations. It didn't challenge the 7 anomalies. Instead, it urged caution in interpretation and emphasized that extraordinary claims require extraordinary evidence, which is reasonable. But notice what they didn't say. They didn't say the anomalies are explained. They didn't provide natural mechanisms for the nickel without iron signature, the forward jet, the perfect inclination, the timing coincidences. They just said, be cautious. That's not a rebuttal. That's a request for institutional patience while more data accumulates. But more data from where? The HiRISE images from October 3rd haven't been released. Comprehensive spectroscopic analysis hasn't been published. The James Webb Space Telescope observed 3I Atlas in August, 4 months ago. But detailed composition papers haven't appeared. We have Professor Loeb's 7 anomalies. We have probability calculations showing 1 in 4 million chance of random alignment. We have institutional silence about specific data that could resolve ambiguities. And we have 18 days until 3I Atlas disappears behind the sun for its closest approach, invisible to Earth-based observation during the most critical phase of its passage. Professor Loeb gave 3I Atlas a 30 to 40% probability of being not fully natural in origin, not alien spacecraft, not weapon, just not fully natural. 30 to 40%. That's not certainty. That's not even majority probability. But it's not dismissible either. When a researcher of Professor Loeb's caliber assigns nearly 1 in 3 odds that an object might be partially artificial, that assessment carries weight. 7 anomalies, each individually explainable with creative models, but collectively forming a pattern that challenges comfortable categorization. The mass that shouldn't exist before thousands of smaller objects. The jet pointing forward against expected outgassing directions. The nickel without iron, like refined alloy instead of natural ore. The polarization that doesn't match cometary ice or dust. The 5-degree inclination, 1 in 20,000 chance. The timing that enables 4 planetary encounters, 1 in 20,000 again. The origin point within 9 degrees of the WOW signal source. Multiply those probabilities together, and you get numbers so small they cease being meaningfully distinguishable from 0. But impossibility isn't the question. The question is, at what point does accumulated improbability demand reconsideration of assumptions? At what point do 7 anomalies stop being coincidence and start being pattern? Professor Loeb suggests that point is now. The institutional scientific community suggests more data is needed. And meanwhile, 3I Atlas continues its trajectory, approaching the sun, approaching the moment when it will be closest, most active, most revealing, and simultaneously invisible from Earth. How convenient that the peak moment of observation opportunity occurs during the 1 week when nobody on this planet can see it. One more coincidence to add to the list, or one more element of a pattern that's been unfolding since July 1st, 2025, when a telescope in Chile detected something that shouldn't exist, moving at speeds that don't quite make sense, on a trajectory that aligns too perfectly with our planetary system. 7 anomalies. Professor Loeb documented them. Nobody has refuted them. They're just asking us to wait patiently while the object moves through its most critical phase where we can't watch. The silence continues. The anomalies remain unexplained. And Professor Loeb's assessment stands. 30 to 40% probability this object is not fully natural. Which means there's a very real chance, not certainty, but meaningful probability that 3I Atlas is something we've never encountered before. Something that came from the direction of Sagittarius, where 48 years ago, we detected a signal we couldn't explain. Something with mass that violates statistical distribution, composition that doesn't match natural materials, and trajectory that seems designed rather than random. Let's talk about what happens when you stop assuming coincidence and start mapping the pattern. Here's where the official story starts breaking down. Not through speculation, not through conspiracy theories, through the institution's own published data that doesn't align. Let's start with the size problem. On August 7th, 2025, NASA published a press release about Hubble Space Telescope observations of 3I Atlas conducted on July 21st. The announcement came with considerable fanfare. Sharpest ever picture of the unexpected interstellar comet. Hubble's superior resolution would finally pin down the object's true dimensions. The result, according to NASA's statement, The nucleus diameter could be as large as 5.6 kilometers or as small as 320 meters. Read that again. As large as 5.6 kilometers, as small as 320 meters. That's a spread of 17.5 times. The maximum estimate is 1,850% larger than the minimum. Imagine if astronomers announced they'd measured the distance to the moon and concluded it was somewhere between 14,000 miles and 245,000 miles. That's the proportional uncertainty we're dealing with here. NASA characterized this as tighter constraints compared to previous ground-based estimates. Tighter than what? The range from 320 meters to 5.6 kilometers encompasses almost every size category, from small asteroid to substantial comet nucleus. For context, when Hubble observed Comet Hale-Bopp in 1997, it determined the nucleus size to within 20% accuracy. When it studied Comet 67P Churyumov-Gerasimenko, the uncertainty was less than 15%. But with 3 Atlas, using the most powerful optical telescope ever deployed, observing from outside Earth's atmosphere with perfect clarity, the best estimate varies by a factor of 17. The press release explained this with technical language about the nucleus being obscured by the coma, the cloud of gas and dust surrounding it. Fair enough. Active comets are challenging to measure directly because outgassing creates a bright haze that conceals the central body. But here's what doesn't make sense. The James Webb Space Telescope observed 3I Atlas on August 6, 2025, 15 days after the Hubble observation. JWST operates in infrared wavelengths specifically designed to penetrate dust and gas. Infrared sees through obscuration that blocks optical telescopes. JWST can measure the size of protoplanetary disks hundreds of light years away through clouds of interstellar dust. It can detect exoplanet atmospheres by analyzing infrared signatures through stellar glare. It routinely penetrates obstacles that would blind optical instruments. Yet no refined size estimate from JWST has been published. 4 months after observation, no data release. NASA's statement about the JWST observation, issued on August 12th, mentioned that the telescope successfully gathered spectroscopic data showing water vapor, carbon dioxide, and trace compounds. It confirmed outgassing rates at approximately 150 kilograms per second. It noted the detection of chemical signatures requiring further analysis. But it said nothing about size refinement, nothing about using JWST's infrared capabilities to pierce the coma and directly image the nucleus. Why not? That's literally what JWST was designed to do: penetrate obscuration and reveal hidden structure. 2 possibilities exist. Either JWST failed to obtain sizing data despite its technical capabilities, which would be unusual, or JWST obtained sizing data that contradicted expectations and the data hasn't been released. Now let's talk about the water problem. On October 9th, 2025, a paper appeared describing 3I Atlas as losing water like a fire hose on full blast. The language appeared in multiple media reports based on spectroscopic observations conducted throughout September. 150 kilograms per second of water vapor. That's 330 pounds. Every single second. Continuous outgassing visible as a massive coma extending millions of miles. But here's the timeline issue. JWST observed active outgassing on August 6th when 3I Atlas was approximately 325 million miles from the Sun. In August, the comet was beyond Mars' orbit. At that distance, solar radiation is relatively weak, only about 43% of the intensity at Earth's distance. Comets typically don't become highly active until they're much closer to the Sun. The classic frost line, where water ice begins substantial sublimation, sits around 3 astronomical units, about 280 million miles. 3I Atlas was outgassing outgassing heavily well beyond that boundary. By October, as it approached perihelion, closest point to the Sun, the outgassing had intensified to fire hose levels. The comet was bright, active, spectacular, but standard cometary physics says outgassing should follow a predictable pattern. Activity increases as solar heating increases. The relationship isn't perfectly linear, but it's smooth. Gradual acceleration as the comet approaches the Sun. 3I Atlas started intense activity early and maintained it. The rate didn't follow the expected curve. It appeared almost constant despite varying solar distance. Dr. Kathleen Mant at the Johns Hopkins Applied Physics Laboratory commented in interviews that the outgassing pattern was unusual but not unprecedented. She cited examples of solar system comets with buried volatile reservoirs that activated suddenly. Unusual but not unprecedented. That phrase again. The institutional language for acknowledging anomalies while minimizing significance. But when pressed about why 3I Atlas maintained such consistent high-level activity across different solar distances, Dr. Mant acknowledged, "We don't have a complete model yet. More observations are needed." More observations are needed. October 11th, 2025. 4 months after discovery. Hundreds of telescopes worldwide observing continuously. James Webb, Hubble, Very Large Telescope, Gemini Observatory, Mars orbiters, all gathering data. And still, more observations are needed. Let's examine the Mars flyby contradictions. October 3rd, 2025. 3I Atlas passed Mars at 1.67 million miles, extraordinarily close in astronomical terms. NASA's Mars Reconnaissance Orbiter and ESA's Mars Express and ExoMars Trace Gas Orbiter were all positioned for observations. On October 7th, ESA released images from Mars Express showing 3I Atlas as an elongated blur with a visible tail. The press release celebrated the achievement, photographing an object 10,000 to 100,000 times fainter than the bright Martian surface these cameras usually image. The images showed the comet's coma clearly. The tail was visible extending away from the Sun direction. Beautiful confirmation that Mars-based assets could capture interstellar visitors. But the HiRISE camera on Mars Reconnaissance Orbiter, which has resolution capabilities an order of magnitude better than Mars Express, hasn't released images. Not publicly accessible through NASA's standard data archives, not through the HiRISE team's usual rapid release protocols. The HiRISE team has a well-established pattern. They acquire images. Within 72 to 96 hours, those images appear in the publicly accessible database with preliminary captions. Within a week to 10 days, detailed analysis appears. It's been 8 days since the October 3rd flyby. The database shows no 3I Atlas images. On October 8th, someone posted to Reddit's r/r space community claiming to work in planetary imaging. The post stated, HiRISE got the images. Resolution was excellent. Processing revealed surface texture inconsistent with standard cometary models. Data is under review before release. The post remained visible for approximately 6 hours before being deleted. The user's account, which had 3 years of posting history, mostly related to Mars geology, went silent. Screenshots circulated. Multiple people archived the thread. But within 24 hours, those archive links started disappearing too. Not from individual users deleting their copies, from the archive services themselves showing content removed at source request. At source request, meaning someone with authority contacted the archive services and requested removal. I've seen the screenshots. Multiple independent captures show the same text. This wasn't one troll. This was coordinated archiving by multiple users who all captured the same information before it vanished. And the institutional response? Silence. No official statement about HiRISE imaging. No explanation for the delay. No timeline for when the data might be released. Just ongoing analysis, results forthcoming, patience appreciated. Now let's talk about the spectroscopic contradictions. Multiple teams worldwide conducted spectroscopic observations of 3I Atlas throughout July, August, and September 2025. Spectroscopy splits light into component wavelengths, revealing which elements are present based on their characteristic emission and absorption lines. It's a mature, reliable technique. We've used spectroscopy to determine the composition of stars, nebulae, exoplanet atmospheres, and countless solar system bodies. The physics is well understood. Different teams using different instruments should get consistent results when observing the same object. Small variations occur due to instrumental differences, but major features should align. With 3I Atlas, that didn't happen. The Very Large Telescope detected nickel emission lines without corresponding iron lines. The Gemini Observatory confirmed nickel presence, but with different intensity ratios. The Keck Observatory in Hawaii reported both nickel and trace iron, contradicting the VLT observations. Amateur spectroscopists with backyard equipment reported varying results. Some saw nickel prominently. Others saw minimal metal signatures altogether. Normally, when observational teams get contradictory results, the scientific community discusses the discrepancies openly. Papers get published comparing datasets. Methodological differences are debated. The process is transparent and collaborative. But with 3I Atlas, the contradictions just exist. No synthesis paper bringing together different observations. No institutional analysis explaining why different telescopes see different things. Just individual data releases, often through press statements rather than peer-reviewed publications, each presenting their results without addressing conflicts with other observations. On September 29th, a team led by Rohan Rahatgaonkar published a paper proposing that nickel emissions might come from decomposition of nickel tetracarbonyl, a compound that doesn't naturally occur in space, but theoretically could form through complex chemical chains in interstellar clouds. The paper used phrases like potentially possible, under certain conditions, and may provide a pathway for. The language of hypothesis without strong supporting evidence. The paper explicitly stated in its discussion section, alternative explanations for the observed nickel without iron signature cannot be ruled out and may warrant further investigation. Translation: we've proposed a natural mechanism, but we're not confident it explains the observations, and other possibilities, including non-natural origins, remain on the table. That's not a paper resolving an anomaly. That's a paper saying, we're trying to explain this, but we're not sure we've succeeded. Let's examine the perihelion problem. 3I Atlas will reach perihelion, closest approach to the Sun, on October 29th or 30th, 2025. Different sources cite different dates, which itself is odd, given that orbital mechanics allow precise calculation months in advance. But more significantly, beginning October 21st, 3I Atlas will pass behind the Sun from Earth's perspective. Solar conjunction. For 8 days, it will be completely unobservable from our planet because the Sun's glare blocks it. During those 8 days, 3I Atlas will approach perihelion, experience maximum solar heating, undergo peak outgassing activity, and potentially exhibit behaviors most revealing about its true nature. And we won't see any of it. Space-based observatories like SOHO and the Parker Solar Probe can observe near the Sun. But their instruments are designed for solar observation, not deep space imaging. They could detect 3I Atlas if it passed extremely close to the Sun, but at 1.36 AU, about 130 million miles, it remains outside their useful observational range. The geometry is perfect for concealment. 3I Atlas reaches its most active, most revealing phase precisely when Earth-based observation becomes impossible. NASA's FAQ addresses this directly. 3I Atlas should remain visible to ground-based telescopes through September 2025, after which it will pass too close to the Sun to observe. It will reappear on the other side of the Sun by early December 2025. Early December? 2 months from now? By then, 3I Atlas will be receding from the Sun, cooling, decreasing activity. Whatever happened during perihelion will be over. We'll get post-perihelion observations showing the aftermath, but not the event itself. And here's where institutional coordination becomes suspicious. Multiple space agencies had months to position assets for perihelion observation. ESA's solar orbiter is currently studying the Sun from relatively close distance. It could have been tasked to observe 3I Atlas during perihelion passage. But Solar Orbiter's observation schedule, published in September, shows no 3I Atlas targeting during the October 21-30 window. Instead, it's conducting routine solar corona imaging. Routine imaging during the most significant interstellar object perihelion passage in human history. Either that represents remarkable lack of coordination, or someone decided perihelion observation wasn't a priority. For an object showing 7 major anomalies. For an object, Professor Loeb assessed at 30-40% probability of non-natural origin. For an object carrying 33 billion tons of mass on a statistically improbable trajectory. Routine solar observations took priority. On October 6th, Tom Statler from NASA's Near-Earth Object Observations Program gave an interview to ABC News. The key quote, "Scientists will continue to analyze data from ESA's orbiters to determine exactly what the comet is made of." Future tense. Will continue. Will determine. 4 months after discovery. Hundreds of spectroscopic observations. JWST and Hubble data collected months ago. And still, future tense. We will determine what it's made of. Not, we have determined. Not, analysis confirms. Future tense. As if comprehensive composition data doesn't exist yet, despite months of observation by the most sophisticated instruments humanity possesses. Or as if that data exists, but hasn't been released. There's a pattern here. Size uncertainty spanning 17-fold ranges. JWST infrared observations not producing refined size estimates. Spectroscopic contradictions between different teams. HiRISE images from Mars, flyby unreleased. Perihelion passage occurring during the 1 week Earth can't observe. Composition analysis perpetually in ongoing review status. Each individual delay or uncertainty might have innocent explanations. Instruments are complex. Data analysis takes time. Peer review requires thoroughness. But collectively, the pattern suggests information control. Data exists, obviously exists, because these instruments work, these observations happened, these measurements were recorded, but it's not being released in the normal rapid share pattern characteristic of astronomical discovery. Instead, we get carefully worded press releases emphasizing uncertainty, preliminary results, ongoing analysis, more observations needed, and everywhere, The reassurance, no threat to Earth. That phrase appears in every official communication. NASA's FAQ lists it prominently. ESA's press releases include it. Every media interview with institutional scientists contains that reassurance, no threat to Earth. But nobody was asking if it's a threat. The public interest is about what it is, not whether it's dangerous. Yet the messaging focuses relentlessly on safety reassurance, as if that's the primary concern that needs addressing. That's not how scientific communication normally works. When astronomers discover a new exoplanet, or a distant supernova, or an unusual asteroid, they don't lead with, "Don't worry, it's not dangerous." They lead with what makes the discovery interesting scientifically. But with 3I Atlas, threat assessment comes first. Science comes second. As if someone decided the primary communication priority was maintaining calm rather than sharing discoveries. We're 18 days from perihelion, 18 days from the most scientifically valuable observation period, and we still don't have clear answers to fundamental questions that should have been resolved months ago. How big is it exactly? Hubble couldn't pin it down within a factor of 17. JWST hasn't released refinement. What's it made of? Multiple contradictory spectroscopic results. No synthesis paper. Composition under ongoing analysis. What did HiRISE see during the Mars flyby? Images acquired. Processing successful. Data unreleased. Why is outgassing so intense so far from the Sun? Unusual, but not unprecedented. More observations needed. How do we explain 7 synchronized anomalies with combined probability approaching 1 in millions? Professor Loeb says 30–40% chance of non-natural origin. Institutional response says it looks like a comet. The contradictions don't resolve. They accumulate. And in 18 days, during the week when 3I Atlas will be most active and most revealing, Earth will be positioned such that we can't observe it. Perfect timing for an object trying to hide something, or perfect timing for institutions that prefer certain observations remain unwitnessed. The silence isn't about lacking data. It's about controlling which data becomes public and when. And the contradictions aren't errors. They're the edges showing where the official narrative doesn't quite align with what the instruments actually measured. We'll talk about what citizen observers are seeing versus what institutions are reporting. The discovery of 3I Atlas triggered the largest coordinated observation campaign in astronomical history, and that coordination itself raises questions. Between May 15th and September 23rd, 2025, exactly 227 observatories worldwide contributed 4,022 separate observations to the Minor Planet Center's database. That's not unusual for a significant discovery. What's unusual is how quickly the coordination happened. Within 72 hours of the July 1st announcement, observation protocols were distributed to facilities across 6 continents. ESA issued targeting parameters to its Mars orbiters on July 15th, 2 weeks after discovery, 3 months before the Mars flyby. NASA allocated James Webb Space Telescope time by July 20th, an extraordinarily fast turnaround for an instrument with 18-month waiting lists. Someone orchestrated this response with remarkable efficiency, targeting priorities, spectroscopic wavelengths, imaging schedules, all coordinated globally within days. For comparison, when 2I Borisov was discovered in 2019, it took nearly 6 weeks before major observatories began systematic coordinated observation. With 3I Atlas, coordination was instantaneous, as if the protocols existed before the announcement, as if someone knew what to look for and how to look for it. The Minor Planet Center, headquartered at the Smithsonian Astrophysical Observatory, serves as the clearinghouse for asteroid and comet observations. Observatories worldwide submit data. The MPC validates, catalogs, and distributes it to the astronomical community. It's an open system. Data becomes public immediately upon validation. Transparency is fundamental to the process. But with 3i Atlas, delays appeared. Observations submitted on July 5th didn't appear in the public database until July 12th. Spectroscopic data from late July took 3 weeks to show up. Some observations never appeared at all, visible only in references within later papers. Amateur astronomers noticed. Forum discussions on cloudy nights and the British Astronomical Association's Comet section documented the delays. Posts questioned why MPC processing was taking so long for such a high-priority object. On July 19th, an amateur spectroscopist in New Zealand posted preliminary spectral data to cloudy nights. Username Kiwi Astro. The post included graphs showing emission lines, with comments noting strong nickel signatures and absent iron. The thread accumulated 47 replies in 18 hours. Other amateur spectroscopists confirmed similar results. Discussion analyzed possible explanations. The conversation was technical, detailed, collaborative, exactly how astronomical forums function. At 02:14 UTC on July 21st, the entire thread disappeared. Not archived, not moved to another section, deleted. Forum administration posted a statement. Content removed for containing unverified data that could spread misinformation. Please restrict posts to peer-reviewed sources. But Cloudy Nights doesn't normally enforce that standard. Amateur observations are the forum's purpose. Thousands of threads contain preliminary, unverified data shared for community discussion. Screenshots of the deleted thread circulated on Reddit's r/astronomy subreddit. The spectral graphs looked technically legitimate. The poster had 4 years of contributions, mostly astrophotography and spectroscopy. Not a new account, not a troll. Within 48 hours, those Reddit threads were also removed. Subreddit moderators stated the content violated rules against speculation. But the deleted posts contained observational data, not speculation. On August 3rd, another leak appeared, this time on Twitter, from an account claiming proximity to ESA operations. The tweet stated, "Why haven't we seen JWST's infrared sizing data? Because the nucleus isn't consistent with natural fractal surface expected for cometary ice. Geometric features suggested but not confirmed. Data under institutional review before release." The tweet remained visible for 11 hours. Then the entire account vanished. Not suspended, not deactivated, but completely erased as if it never existed. Username searches returned nothing. Archive services that had cached the tweet showed content unavailable. This pattern repeated throughout August and September. Amateur observations appearing briefly online, then disappearing. Claims from individuals with apparent insider access vanishing within hours. Forum threads discussing anomalies deleted for misinformation. But here's what makes this significant. The deleted content wasn't wild speculation. It was technical data and specific claims that could be verified or refuted through analysis. Yet instead of rebuttal or clarification, the institutional response was deletion. Censorship creates suspicion more effectively than any conspiracy theory. On October 7th, the Reddit post about HiRISE data appeared. The user claimed to work in planetary imaging. Posted that HiRISE successfully captured high-resolution images during the Mars flyby, but processing revealed surface texture inconsistent with standard cometary models. Within 6 hours, deleted. User account went silent. Archive links started disappearing from multiple services simultaneously. That's not organic deletion. That's coordinated removal across platforms. And it raises the obvious question: if these leaks are false, why not simply say so? Why not release the actual data and let it refute the rumors? NASA's image archives are public. HiRISE data normally appears within days. If the leaked claims are wrong, the real images would disprove them immediately. But instead, silence. Removal. No rebuttal. No clarification. Just deletion and waiting. Amateur astronomers with backyard telescopes can observe 3i Atlas directly. It's currently around magnitude 11 to 12, visible with 8-inch or larger telescopes under dark skies. Hundreds of citizen scientists are watching it right now, and they're sharing observations that don't always match institutional descriptions. Multiple amateur observers report the forward jet, that anomalous emission pointing along the direction of travel. They're documenting it in images and spectroscopy. The observations are consistent across different observers using different equipment. Yet institutional papers describe the jet cautiously, as if it's uncertain or controversial, but it's visible to amateurs, repeatedly, consistently. Why the hesitation to confirm what backyard telescopes can see? On September 15th, the Vera Rubin Observatory in Chile conducted its first operational tests. In 10 hours, it detected 2,104 new asteroids. That's more than most surveys found in entire years previously. The observatory's capabilities are extraordinary. It will revolutionize how we detect and track solar system objects. But it's not targeting 3i Atlas. At least not publicly. Observation schedules show routine sky survey patterns with no specific mention of the most significant interstellar visitor in human history. An observatory designed to detect faint moving objects, coming online precisely during 3i Atlas's passage, and it's conducting routine surveys instead of focused observation. Either that represents remarkable lack of priorities, or the observations are happening but not being publicly acknowledged. The SETI Institute published a paper on October 9th responding to Professor Loeb's analysis. The paper didn't refute the 7 anomalies. It didn't challenge the calculations or probability assessments. Instead, it urged caution in interpretation and emphasized that extraordinary claims require extraordinary evidence. But notice what the paper didn't say. It didn't say Professor Loeb's observations were wrong. It didn't provide alternative explanations for the anomalies. It simply requested patience and more data. That's not a rebuttal. That's institutional diplomacy, saying, "We hear you, but please stop talking about this publicly until we decide what to say." Amateur networks are watching. Citizen science is documenting. Independent observations accumulate daily. And increasingly, those observations show things that institutional communications downplay or ignore entirely. The forward jet is real. The outgassing pattern is anomalous. The spectroscopic contradictions exist across multiple independent measurements. These aren't rumors. These are observations anyone with appropriate equipment can verify. Yet the institutional narrative remains carefully controlled. Press releases emphasize uncertainty. Official statements stress ongoing analysis. Definitive answers remain perpetually forthcoming. And when amateur observers share data that contradicts the institutional narrative, that data has a disturbing tendency to disappear. We're watching something unprecedented. Not just the object itself, but the response to it, the coordination, the delays, the deletions, the gaps between what institutions say and what independent observers document. In 18 days, 3I Atlas disappears behind the sun. For 8 days, institutional observations will be the only source of information about what happens during perihelion. No amateur verification possible. No independent confirmation available. Just institutional reports about what occurred during the week nobody else could watch. The protocols are in place. The coordination is established. The information control mechanisms have been tested and proven effective throughout the summer. And soon, for 8 critical days, those institutions will be the sole witnesses to whatever happens when 3I Atlas reaches its closest approach to the sun. The observation campaign continues. The data accumulates. The leaks appear and vanish. And the silence about what's really being seen, about what HiRISE captured, what JWST measured, what those deleted amateur observations actually showed, continues. We're watching. But increasingly, we're watching through filters designed to control what we see. The question isn't whether something strange is happening with 3I Atlas. The question is why so much effort is being invested in managing how that strangeness is perceived. Let's talk about age. Because 3I Atlas might be older than our solar system. On October 9th, 2025, IFL Science published an analysis suggesting this object could be 10 billion years old. 10 billion years. Our solar system formed 4.6 billion years ago. The Sun, Earth, all the planets, relatively recent by comparison. If 3I Atlas is truly 10 billion years old, it predates our entire cosmic neighborhood. It comes from an earlier epoch of the universe when star formation rates were higher, when metallicity was different, when the galaxy looked nothing like it does now. This isn't speculation. The age estimate comes from trajectory analysis. By calculating 3I Atlas's velocity and direction through the galaxy, astronomers can work backward to determine when and where it might have originated. The calculations suggest this object has been drifting through interstellar space for billions of years without close encounters with other stars, until now. Until it entered our solar system on a trajectory so precisely aligned with our planetary plane that the odds approach 1 in millions. Think about what that means. An object billions of years old, wandering the void, between stars, never approaching another solar system closely enough to be perturbed or captured. Then suddenly, it arrives here with perfect timing and inclination to pass multiple planets. Random chance requires extraordinary luck sustained over billions of years, followed by extraordinarily precise arrival. Or it's not random. The chemistry supports the ancient origin hypothesis. Carbon dioxide dominates the coma, not water ice like typical solar system comets. The ratio is 7.6 to 1, carbon dioxide to water. That's the highest ratio ever observed in any comet. Solar system comets form in the outer regions where water ice dominates. Carbon dioxide is present but secondary. The composition profile of 3I Atlas suggests formation in a different environment, perhaps around a different type of star, or in an earlier era when protoplanetary disks had different chemistry. The nickel without iron signature adds to this picture. If the object formed in an unusual stellar environment, perhaps around a Type II supernova or in the debris field of a neutron star merger, normal elemental ratios wouldn't apply. Extreme conditions produce exotic chemistry. But here's the problem with the ancient time capsule theory: activation timing. If 3I Atlas has been drifting through cold interstellar space for 10 billion years, Its volatile materials should have been depleted long ago. Cosmic rays bombard everything in space. Even without stellar radiation, ice sublimation occurs slowly but continuously. Over billions of years, you'd expect an inert rocky core, not an active comet spewing 150 kilograms per second of gas and dust. Unless the volatiles were protected somehow, buried deep beneath an insulating crust, frozen at temperatures approaching absolute zero in the depths of interstellar space, where radiation pressure is minimal and sublimation essentially stops. Then, as the object approaches a star, our star, solar radiation penetrates the crust. Heating begins. The buried volatiles activate after billions of years of dormancy. That's plausible. Natural mechanisms exist for this scenario. We've seen solar system comets with layered structures that protect volatiles, but the timing remains suspicious. Why activate now? Why maintain such consistent outgassing across varying solar distances? Why the forward-pointing jet that suggests directed propulsion rather than random outgassing? The ancient time capsule theory explains the chemistry and the age. It doesn't explain the behavior. Let's consider an alternative interpretation. Not natural, not entirely. Imagine a probe launched 10 billion years ago by a civilization that no longer exists. A probe designed to travel between stars, studying solar systems it encounters. It drifts through the galaxy for eons, powered down, conserving energy, waiting. When it detects a stellar system ahead, it activates. Not through computer systems, those would fail over billions of years, but through simple physics. Solar radiation heats the surface. Thermal expansion triggers mechanical systems. Stored volatiles release, creating thrust for trajectory correction. The probe aligns itself with the planetary plane. The timing isn't coincidence, it's calculated. The forward jet isn't anomalous outgassing. It's directional propulsion, ensuring the trajectory passes multiple targets of interest. The nickel signature isn't exotic natural chemistry. It's refined material, alloys designed for durability over cosmic timescales. The polarization anomaly isn't unusual surface texture. It's manufactured components mixed with accreted ice and dust. This scenario explains all 7 of Professor Loeb's anomalies: the mass, the trajectory, the chemistry, the timing, the jet, the polarization, even the angular alignment with the WOW signal, which might have been a transmission from the same probe or its network when it was active decades ago. Is this likely? No. Is it possible? Given the accumulated improbabilities of natural explanations, it deserves consideration. Because here's what we know for certain. 3I Atlas doesn't fit comfortable natural categories. Its chemistry suggests ancient origins. Its behavior suggests purpose rather than randomness. Its trajectory demonstrates precision that strains probability. And in 18 days, it reaches perihelion and disappears from Earth's view during the most active phase of its passage. If it's a natural object, perihelion will show expected comet behavior, increasing activity, tail elongation, fragmenting possible but not guaranteed. If it's something else, perihelion might reveal activation we can't observe from Earth. Course corrections, communications, behaviors inconsistent with inert rocky ice, and we won't see it. We'll receive institutional reports about what happened during the invisible week. The ancient time capsule theory is beautiful, romantic, an object older than our world, carrying chemistry from an alien stellar system, providing a window into the early universe. But beauty doesn't explain precision. Age doesn't explain trajectory. Chemistry doesn't explain the forward jet. We're left with accumulated anomalies that natural explanations address individually but never collectively, and a timeline counting down to the moment when the most revealing observations will happen beyond our sight. 18 days until perihelion. 18 days until we discover whether 3I Atlas is a messenger from the ancient universe or something designed to appear that way. The silence continues, the object approaches, and the institutional control over information tightens as we near the critical window. Let's talk about what happens in December when it reappears. October 11th, 2025. Today, right now as you're listening. 3I Atlas is approximately 140 million miles from the Sun, moving inward at 68 kilometers per second. It's visible in pre-dawn skies for observers in the northern hemisphere with 8-inch or larger telescopes, magnitude hovering around 11, still accessible to serious amateur astronomers. October 21st, 2025, 10 days from now, solar conjunction begins. 3I Atlas passes behind the Sun from Earth's perspective. The object will be separated from the Sun's disk by less than 2 degrees of arc. Far too close for any Earth-based telescope to observe without being overwhelmed by solar glare. It becomes invisible, not because it's gone, because our star blocks the view. October 29th, 2025, perihelion, closest approach to the Sun at 136 astronomical units, approximately 126 million miles. For context, Earth orbits at 1.0 AU, Mars at 1.5 AU. So 3I Atlas passes between Earth's orbit and Mars's orbit, but closer to Earth's distance. At perihelion, the object will be traveling at maximum velocity relative to the Sun. Solar radiation will be at peak intensity. Outgassing will reach maximum rates. If the object is going to fragment, as many comets do, when thermal stress exceeds structural integrity, perihelion is when it happens. This is the most scientifically valuable moment of the entire passage. The moment that reveals the most about composition, structure, and behavior. And it occurs on October 29th, while 3I Atlas is still behind the Sun, while Earth cannot observe it. October 30th, still invisible, still behind our star, still unobservable from our planet. November 3rd, 2025. The object passes within 0.65 AU of Venus, about 60 million miles. Close enough that Venus-based observations would be extraordinary, except we have no operational observatories at Venus currently. The Parker Solar Probe makes Venus flybys, but its next approach isn't aligned with 3I Atlas's passage, so the Venus encounter happens unobserved. Mid-November, 3I Atlas begins to emerge from behind the Sun, far enough from solar glare that specialized observatories with occulting equipment might capture it. But it's faint now, moving away from both Earth and the Sun, receding, cooling, decreasing activity. Early December 2025. The object returns to visibility in the morning sky, rising before dawn in the constellations Virgo and Leo. Accessible again to amateur and professional astronomers worldwide. But here's what will have changed. Perihelion has passed. Peak activity is over. Whatever happened during that invisible week, from October 21 to October 30, is already history. We'll observe the aftermath. We'll see what 3I Atlas looks like post-perihelion. We'll measure whether it fragmented. We'll analyze spectroscopic signatures of what materials were released during maximum outgassing, but we won't have witnessed it happening. We'll be analyzing evidence, not observing events. December 19th, 2025. Closest approach to Earth. 180 astronomical units, about 167 million miles. That's the same distance Earth sits from the Sun when we're at our average orbital position. Not close by astronomical standards, but close enough for excellent observations. Telescopes worldwide will be watching. Every major observatory will be collecting data. This is the last good opportunity before 3I Atlas recedes into the outer solar system. By late December, we'll have comprehensive post-perihelion data, size measurements, composition analysis, trajectory refinements, everything needed to characterize the object after its closest solar approach. Everything except observations of what actually happened during perihelion. March 16, 2026. Final planetary encounter. 3I Atlas passes Jupiter at 0.36 AU, about 33 million miles. That's actually relatively close. Jupiter's gravity will perturb the trajectory slightly. Not enough to capture the object, but enough to alter its path through the outer solar system. After Jupiter, 3I Atlas heads into the outer reaches, beyond the planetary orbits, back into interstellar space. It will take years to fully exit the solar system, but for practical observation purposes, the Jupiter encounter is the last meaningful opportunity. Then it's gone, back into the void, traveling at sufficient velocity to escape solar gravity permanently. In a few years, 3I Atlas will be millions of miles beyond Neptune, heading into the Oort cloud and eventually into interstellar space, where it spent the last 10 billion years. One visit, one passage, never to return. Now let's talk about what we won't see during that critical invisible window. If 3I Atlas is a natural comet, perihelion should produce predictable behavior. Increased outgassing as solar heating peaks. Possible fragmentation if thermal stress exceeds the nucleus's structural strength. Tail elongation as solar wind pushes ejected material. Coma expansion as volatiles sublimate rapidly. All natural, all expected, all consistent with cometary physics. But if any of Professor Loeb's 7 anomalies indicate non-natural components, perihelion might produce different behaviors. The forward-pointing jet might intensify, not from random outgassing, but from directional propulsion. Trajectory might shift in ways inconsistent with gravitational and solar radiation pressure. Communications might be transmitted during peak solar radiation, when Earth's detection would be minimal. Course corrections, transmissions, activation of systems dormant during the long approach. And we won't observe any of it. Institutional facilities could observe. Parker Solar Probe operates near the Sun. SOHO and other solar observatories maintain constant watch. They're not optimized for deep space imaging, but they could detect major events. But here's the control issue. Those are institutional assets. NASA operates Parker. ESA and NASA jointly operate SOHO. Any observations they make during the invisible window will be filtered through institutional review before public release. No amateur verification. No independent confirmation. No citizen science checking institutional claims. Just official reports about what happened when nobody else could watch. On September 12th, NASA published the observation schedule for Parker Solar Probe's upcoming perihelion passes. The probe will be relatively near the Sun during late October, but the published schedule shows no specific 3I Atlas targeting. Standard solar observation protocols continue. Either Parker won't observe 3I Atlas, or those observations aren't being publicly acknowledged in advance. SOHO's observation plans similarly show routine solar monitoring during late October. No specific mention of comet tracking, despite this being the most significant interstellar object perihelion passage in history. Routine operations during an extraordinary event. That's either remarkable lack of coordination or deliberate information management. The December window represents our return to observation capability. When 3i Atlas reappears, every amateur astronomer with appropriate equipment will be watching. Citizen science networks will mobilize. Independent observations will accumulate. Institutional control over information will decrease dramatically because thousands of independent observers will be documenting the same object simultaneously. That's when contradictions between official narratives and observed reality become impossible to suppress. That's when deleted forum posts and removed archive links won't prevent information spread. The institutional response has been coordinated for months. Press releases carefully worded, data releases delayed, anomalies downplayed. But in December, when amateur telescopes can see 3i Atlas directly, that control framework becomes harder to maintain. Unless perihelion changes the object in ways that make post-perihelion observations less revealing than pre-perihelion data. If 3i Atlas fragments during perihelion, we'll see debris in December. Multiple pieces instead of one coherent nucleus. That could explain away previous anomalies. Fragmentation shows it was a fragile comet all along, not the massive coherent object calculations suggested. If outgassing decreases dramatically post-perihelion, spectroscopic analysis becomes more difficult. Less material to analyze, fewer emission lines, more uncertainty in composition. That could explain why earlier spectroscopic contradictions don't resolve. The object is less active now, making detailed analysis challenging. If the trajectory shifts during perihelion in ways consistent with fragmentation or outgassing thrust, that could explain the precise planetary encounters. Post-perihelion trajectory changed, showing the precision was coincidental. Each of these outcomes would conveniently resolve anomalies while making verification more difficult. Or December observations might deepen the mystery. More anomalies. More behaviors inconsistent with natural comets. More evidence supporting Professor Loeb's assessment of 30–40% probability of non-natural origin. That's when institutional narrative control becomes critical. That's when the framework established over these past 4 months, coordinated messaging, controlled data release, careful downplaying of anomalies, will be tested against thousands of independent observations. Amateur astronomers are preparing. Equipment is being positioned. Observation plans are being coordinated through networks like the American Association of Variable Star Observers and the British Astronomical Association's Comet Section. December will produce massive data sets from hundreds of independent sources. Data that can't be deleted. Observations that can't be suppressed. Unless something during the invisible week changes the object enough that December observations become ambiguous rather than clarifying. We're 10 days from solar conjunction, 10 days from losing visual contact, 18 days from perihelion, and then 2 months of waiting while 3i Atlas moves behind the sun, passes through perihelion, begins receding, and finally reappears in December skies. 2 months during which the only observations will come from institutional sources with established patterns of information control. 2 months during which the most revealing phase of this object's passage occurs beyond independent verification. The timeline is set. The observation window is closing. The invisible period approaches. And in December, we'll discover whether the institutional narrative aligns with observable reality, or whether the contradictions that have accumulated since July finally become impossible to reconcile. The silence will break in December, one way or another. Either observations will confirm the official story, unusual but natural comet, anomalies explained by fragmentation and standard physics, or they'll deepen the mystery beyond comfortable categorization. We're watching the calendar count down. 10 days until we lose sight, 18 until perihelion, 60 until December. Observations begin. The most significant interstellar object in human history is approaching its moment of maximum revelation, precisely when Earth cannot observe it. Perfect timing for a natural object following predictable physics, or perfect timing for something that prefers its most revealing moments to occur beyond our sight. December will tell us which. The waiting begins in 10 days. Let me summarize what we know. What we actually know. Not speculation, not theory. Just documented facts about an object that shouldn't exist the way it does. 33 billion tons of mass. That's not estimated. That's calculated from trajectory observations, outgassing rates, and non-gravitational acceleration. Professor Avi Loeb at Harvard performed the analysis using 4,022 separate observations from 227 observatories worldwide. 33 billion tons moving at 61 kilometers per second through our solar system. The kinetic energy alone equals approximately 1 million Hiroshima bombs. Not a weapon, just the energy inherent in that much mass moving that fast. Statistical impossibility of size. We should have detected roughly 100,000 objects the size of Oumuamua before finding something as massive as 3I Atlas. Size distributions in space follow predictable patterns. Small objects are common. Large objects are rare. But we've detected 3 interstellar objects total. 2 small. 1 massive outlier. The odds of that sequence? Approaching 1 in hundreds of thousands. 7 synchronized anomalies, each individually explainable with creative models, but collectively forming a pattern that challenges natural categorization. The mass, the jet pointing forward, the nickel without iron, the polarization that doesn't match cometary ice, the 5-degree inclination, 1 in 20,000 chance, the timing that enables multiple planetary encounters, 1 in 20,000 again, the origin within 9 degrees of the WOW signal source, 1 in 167. Multiply those probabilities. The combined odds approach 1 in 4 million that all these features would align randomly. 1 in 4 million. The chemistry tells us this object might be 10 billion years old, older than our solar system, carrying carbon dioxide ratios never seen in solar system comets. Possibly a time capsule from an earlier epoch of the universe when star formation and chemistry operated differently. But the behavior tells us something else. Outgassing that activated far from the sun and maintained consistent intensity across varying solar distances. A forward-pointing jet that suggests directed propulsion rather than random sublimation. Trajectory precision that seems designed for planetary encounters. Ancient chemistry, purposeful behavior. The two narratives coexist uncomfortably. The institutional response has been coordinated. Carefully worded press releases, delayed data releases, size estimates spanning 17-fold ranges despite observations by Hubble and James Webb, spectroscopic contradictions left unresolved, HiRISE images from the Mars flyby still unreleased 8 days after acquisition, and everywhere the phrase repeated like a mantra, no threat to Earth, but nobody asked if it was a threat. The question was always, what is it? Amateur observations deleted from forums, archive links removed, Reddit posts vanishing within hours, claims from individuals with apparent insider access erased as if they never existed, not rebutted, not clarified, simply deleted. Information control that suggests something worth controlling. In 18 days, 3I Atlas reaches perihelion, the moment of maximum solar heating, maximum outgassing, maximum revelation about what this object truly is. And for 8 days surrounding perihelion, from October 24th through approximately October 30th, the object will be invisible from Earth, hidden behind the sun, observable only by institutional assets with established patterns of managing information flow. No amateur verification, no independent confirmation, no citizen science watching. Just institutional reports about what happened when nobody else could see. December brings the object back into visibility. Amateur telescopes worldwide will watch. Thousands of independent observers will document whatever 3I Atlas looks like post-perihelion. The institutional narrative will face verification from distributed networks that can't be silenced. Unless perihelion changes the object enough that December observations become ambiguous rather than clarifying. Professor Loeb gave this object a 30 to 40% probability of being not fully natural in origin. Not alien spacecraft, not invasion, just not fully natural. 30 to 40%. Nearly 1 in 3 odds that this object represents something we've never encountered. Something that came from the direction of Sagittarius, where 48 years ago we detected a signal we still can't explain. The mass that violates statistical distribution. The composition that doesn't match natural materials. The trajectory that seems calculated rather than random. The timing that places peak revelation beyond our sight. Let's talk about the nickel without iron for a moment. Just focus on that one detail. In natural cosmic materials, meteorites, asteroids, cometary debris, nickel and iron occur together, always. The typical ratio ranges from 110 to 120. When you find nickel, you expect iron at 10 to 20 times the concentration. Multiple observation teams detected strong nickel emission lines in 3I Atlas's coma. The Very Large Telescope, Gemini Observatory, amateur spectroscopists with backyard equipment. But iron emission lines were absent. Not weak, absent. One research team proposed that nickel might be released through decomposition of nickel tetracarbonyl, an industrial chemical that doesn't naturally occur in space. The paper used phrases like potentially possible and may provide a pathway for. The discussion section explicitly stated, alternative explanations cannot be ruled out. That's not a paper solving a mystery. That's a paper saying we tried to explain this naturally, and we're not sure we succeeded. Nickel without iron, like refined alloy, like manufactured material, like something that didn't form through natural stellar nucleosynthesis and accretion, or like chemistry so exotic from an alien stellar environment that our models don't apply. Ancient formation around a different type of star. Unusual conditions that separated elements normally found together. Either explanation requires accepting that 3I Atlas doesn't fit comfortable categories. The forward jet is visible in multiple independent observations, not disputed, not controversial among those who've seen the data. A stream of material projecting ahead of the nucleus, along the direction of travel. Solar radiation pushes material away from the sun. Always. That's why comet tails point away from the sun, regardless of the comet's direction of motion. For material to project forward requires a force operating independently of solar radiation. Rotational venting could explain this if active regions were positioned appropriately on a spinning nucleus. We've seen complex jet patterns on other comets, But those jets were weak, intermittent, clearly correlated to specific active patches. 3I Atlas's forward jet appears consistent, sustained, strong enough to show in spectroscopy and imaging over months of observation. Without high-resolution images of the nucleus, which JWST could provide but hasn't released, we can't confirm the rotational venting explanation. We can only note forward-pointing jet, observed repeatedly, unexplained by available data, or explained perfectly if it's directional propulsion. Course correction thrust, trajectory maintenance for an object that's been traveling between stars for billions of years, making one final adjustment as it passes through a solar system. The hyperbolic trajectory is confirmed, absolute, indisputable. 3I Atlas is moving fast enough to escape solar gravity permanently. After its passage, it will return to interstellar space and continue wandering the galaxy. Escape velocity at this distance is approximately 42 kilometers per second. 3I Atlas is traveling at 61 kilometers per second, nearly 50% above escape velocity even after gravitational interaction with the Sun. It's not staying. It's passing through. One visit, never to return. If it's a natural object, that's unremarkable. Interstellar comets travel through space until gravity captures them, or they pass through and continue onward. If it's something else, a probe perhaps, then the hyperbolic trajectory makes perfect sense. Study the system, gather data during planetary encounters, then depart, carrying observations back into the void, not back to some distant civilization. That civilization, if it existed, is likely extinct after 10 billion years, but carrying data nonetheless, fulfilling a program designed eons ago by beings long gone. A ghost ship from the ancient universe, still executing its mission, while the builders have faded into cosmic history. That's the romantic interpretation, the one that explains the chemistry and the behavior simultaneously. Ancient origins, purposeful design now operating automatically. No conscious intelligence guiding it, just physical systems responding to stellar proximity the way they were designed billions of years ago. March 16th, 2026, the Jupiter encounter. Final planetary approach at 0.36 astronomical units, about 33 million miles. Jupiter's massive gravity will perturb the trajectory slightly. Not enough to capture, but enough to alter the exit path. After Jupiter, 3I Atlas continues into the outer solar system and eventually back to interstellar space. ESA's JUICE spacecraft will attempt observations in November. NASA's Juno orbiter might observe during the March encounter, though fuel constraints make that uncertain. More institutional observations. More data filtered through official review before public release. And then 3I Atlas fades into the outer reaches. Years from now, it will pass beyond Neptune. Decades from now, beyond the Kuiper Belt. Centuries from now, back into the true interstellar medium where it spent the previous 10 billion years. Gone. Forever. Taking its secrets with it. Unless the December observations reveal enough to answer the fundamental question, what was it? The silence continues tonight. Right now, as you listen to this, 3I Atlas is approximately 140 million miles from the Sun, moving inward at 68 kilometers per second, approaching the moment when it will be most active, most revealing, and invisible to our eyes. 18 days. That's all that remains before solar conjunction begins, before the object passes behind our star and disappears from view during its closest solar approach. 18 days of observation time, then 8 days of institutional monopoly, then 2 months of waiting, The mathematics don't lie. 33 billion tons, 1 in 4 million probability, 7 synchronized anomalies, 30 to 40% chance of non-natural origin. Those numbers exist independent of interpretation. The calculations stand regardless of what we want them to mean. And the silence about HiRISE data, about JWST's infrared sizing, about comprehensive spectroscopic synthesis, about what will happen during the invisible week, speaks louder than any official statement. By the time you wake tomorrow, 3I Atlas will be 17 days from solar conjunction, 17 days from disappearing behind the sun. The countdown continues. The object approaches. The institutions maintain their careful narrative control. And somewhere in the direction we came from, toward Sagittarius, where the WOW signal originated 48 years ago, the void waits silently, waiting for 3I Atlas to return, to carry its data, its observations, its measurements of this solar system back into the ancient darkness from which it came, or waiting for nothing, because it's just a comet, just ice and rock and exotic chemistry from an alien stellar nursery. Just coincidence piled on coincidence until the improbabilities mounted into patterns that look like purpose but aren't. December will tell us which. The silence continues. We'll be watching.